Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are going to talk about risk management. This episode is based on a tech blog titled Reinventing Risk at Revolut, written by their data science team. You can find the link in this episode's description. Throughout this episode, we will explore this topic from both business and data science angles. Now, let's dive in. On the business side, let's take a look at the problem Revolut set out to solve. Revolut is a United Kingdom-based financial super app. It offers a wide range of services, from banking and investing to budgeting and crypto trading. With more than 60 million users worldwide, it is one of the fastest growing fintech companies today. At a company like Revolut, risk management isn't just a supporting function, it's fundamental for their business. It plays a crucial role in safeguarding customer assets and maintaining regulatory compliance and ensure operational resilience as the business scales globally. But what exactly do we mean by risk? According to International Risk Management Standard, risk is defined as the effect of uncertainty on objectives. In both academic and regulatory contexts, this typically falls into two broad categories. First, financial risk. This associates with positions like customer deposits, lending, or investments in market instruments. Second is operational risk, which stems from breakdowns in day-to-day functions, such as system outages, fraud, or even natural disasters. In practice, though, risks don't usually show up neatly labeled or isolated. They tend to be interconnected. A natural disaster, for instance, might trigger both a system failure and a sharp drop in financial markets. This complexity highlights a challenge in traditional financial institutes. Risk management is often handled by siloed teams, each focused on a single type of risk, either financial risk or operational risk. The operational risk team may deal with fraud and system disruptions, while the market risk team models exposures to interest rate and currency fluctuations. Then, there is the model risk team, which audits the methodologies used by others, essentially managing the risk of risk itself. But this fragmentation setup wasn't designed with today's challenges in mind. It's a byproduct of decades of banking evolution, where every new product or regulatory requirement lead to the formation of another team or reporting structure. The system grew organically, but not strategically, and that makes it fragile. As a newer, tech-native company, Revolut is making a different approach. Instead of replicating legacy banking silos, the team is reimagining risk management to be more integrated and data-driven from the start. Now that we've understood the business problem, let's shift gear and explore the technical side of their solution. Revolut's team set out to build a modern enterprise risk management framework, one that is measurable, comparable, data-driven, and continuously improving. Traditional risk frameworks often rely on static definitions and high-level abstractions. In contrast, the team pursued a bottom-up system rooted in empirical data and scientific reasoning. Their guiding principle was clear: to avoid defining high-level risk concepts unless they can be directly constructed from fundamental scientific elements. If a risk concept can't be derived from these building blocks, either the concept isn't valid or the foundation needs some rethinking. This approach ensured that every layer of abstraction remained grounded in observable and verifiable data, which leads to a framework that is more robust and explainable. At the heart of this system is the concept of an event. An event is broadly defined as a transition between two states over time. This flexibility allows the team to represent a wide variety of occurrences, from failed transactions to fraud attempts. These events can be stacked into a network or graph, creating a flexible and extendable system for modeling real-world risks. This setup offers two main advantages. First, it anchors risk in measurable and granular events. Second, it enables scientific reasoning by adopting a structure similar to a Markov chain, which is a well-known statistical approach for modeling state transitions. Building on this, the team introduced the concept of a chain of events, which is a sequence of causally or logically connected events that together lead to a risk outcome. For example, one risk the team faces involves users with positive account balances that transition into negative balances, and eventually into unrecoverable financial loss. In this case, the relevant states might include positive balance, negative balance, and lost. Transitions can occur between any of these states, and in some cases, a state may remain unchanged, such as the user maintaining a positive balance. Some states, like lost, are considered absorbing, meaning once entered, the system does not transition out of them. To enhance this model, the team also introduced a loss rate, which is the proportion of money likely to be lost in a given state. For simplicity, this example assumes a 100% loss rate, although in practice, there might also be partial losses in the negative balance state due to the collection cost. With this modeling structure in place, the team arrives at a precise and operational definition of risk, which is the potential of financial loss resulting from a chain of events over a given time horizon. This framing borrows from Markov chain theory and the risk graphs, where transitions between states are probabilistic and cumulative over time. To quantify the risk, the team introduced the three core metrics: the maximum loss, which is the worst-case outcome; expected loss, which is the probability-weighted average outcome; and observed losses, which is the actual loss realized from historical data. This metrics gives the team a standard way to measure and compare risks across products and teams and time periods. To get this framework in operation at scale, the team had to overcome several engineering challenges. They leveraged Prometheus, which is an explainable AI platform designed for big data and distributed systems, and this one is used to serve as the framework's reasoning layer. Prometheus abstracts over Revolut's rare state sources and enables rapid iteration using a virtual knowledge graph of facts and business rules. This avoids the need for complex database queries or manual data wrangling. On top of this, Revolut integrates large language models to translate the reasoning layer's outcomes into natural language. This provides human-readable explanations of risks, helping teams understand not just what the risk is, but why it emerged and how it might be addressed. Together, Prometheus and large language models form a powerful tandem for actionable and explainable risk intelligence. Now, we've discussed both the business problem and the technical solution. Let's wrap it up. In this episode, we explored how Revolut is rethinking risk management. By building a modular, scientifically grounded and explainable platform, they enabled faster and more accurate and transparent risk decisions across their global markets and products. If you like the content of this episode, please subscribe to the channel. Give me a 5-star review and leave a comment. Your feedback is very appreciated, and I'll see you next week.